everybody to my session, which is called JDK, the Not So Hidden Tools. A bit about myself. My name is Andrzej Grzesik. I know that it's a bit hard to pronounce, so well, my Twitter handle is much easier. Couple of things you might know me from, or you might, well, connect me with, is a conference called Geekon. I also happen to run the Polish Java user group. I did run or help run the Software Craftsmanship Kraków, and I did found the Kraków Hadoop user group, and all of that, well, half of those activities are now past because I'm still involved in Geekon, but I used to live in Kraków. Now I live in London because it's a fun city to live in. And without further ado, because it's a very short session, as in only 45 minutes, and I know I can talk about an hour and a half and more about this subject, well, let's start with a motivating quote. Well, this is one of my biggest fears, that I will be the most stupid or the least educated person in the world, which will be, well, a good state because I can only learn from everybody else, but it will also mean that, well, I have a lot of things to make up for. So, yeah, I like getting new information because I don't want to be the most stupid person ever. So, who here has Twitter? Yeah, so JDays has a Twitter handle. I have a Twitter handle. If you tweet something during the talk or after, probably both the organizers and me will be very pleased, hopefully. And if you have any questions, try to ask, raise your hands, either scream or wait for the microphone. I'll try to repeat and answer immediately, or if the question is too long or will take too long to answer, I'll just take it after the session somewhere during the lunch break, because this session is 45 minutes only. So without further ado, Java. Well, everybody here knows Java. Some people also know JS, but this talk has nothing to do with Node.js. Java lives in Java home/bin. Yeah, who has ventured into that directory? Yeah, I can see a couple of hands. So some time ago I went into there, listed all the things, and wow, there is a number of tools in there. Well, the first time I ventured in there was a long time ago, and I was actually curious, why isn't my compilation working in NetBeans, but it works in Eclipse, or the other way around, which was a number of years ago when I was, well, still learning the whole widgetry. And then, well, I decided to make a count, and that's 44. So 44 binaries in Java home/bin, which is a lot, which means you can probably do quite a lot things in there, and most of them run in command line, which is awesome. And yeah, out of curiosity, who here is not on Java 8? In production or not in production? Well, who is before? Who is on Java 1.7? Somebody on 6 or earlier? Yeah, that used to be my case up until recently. The idea for this talk is I will show you some tools that work in the command line first. We will end with a tool that's now available in JDK 8 for everybody. That includes all the functionality that we have in here. And because, well, some of you, and that number luckily and happily decreases every time I give this talk, the number of people who are pre-1.7 is, well, it's still above 0. There are some tools that are not available in 1.6, specifically JStudy. So if you're already sleepy or if you haven't woken up yet, just try to log GC. How to do it? Well, you can find excellent blog posts about it. Probably look for something from Kirk Pepperdine or JClarity, or just read Mechanical Sympathy. They will give you a lot of tips. It helps. If you don't know how, well, this is an example how you do that, which means you can add flags to your Java command, which also means that your Java programs will log whenever they do anything with garbage collector. Why is that useful? Because if you have sudden or unexpected performance problems, then you will be able to say if they were happening because of maybe extensive garbage collection, or maybe there is another problem. What to do, how to do it specifically, I won't mention that, and I will not be mentioning all the details and all the funny things you can do with all the tools, because again, simply there is not enough time during this talk. But I want to mention the tools. I want to show you what they can and more or less how they work, so that later, if you need them, or if a customer calls you and says that there is a Java 1.5 machine that needs investigation and it's happening to be in a very remote part of the world which is only accessible via telnet over SSH and you cannot know anything else, or they will have to kill you, your family, and everybody else because it's so secret, then it helps to know. So when things go, you know which way they go. Usually the first reaction is, well, it works on my machine, and then, well, somebody from the server room will tell, yeah, please ship your machine in probably 10,000 of them to our data center, might be in Virginia, might be somewhere else. It's much harder if you want to ship laptops to an Amazon data center. For some reason, they don't want to give you the address and they don't want to accept your laptops. Strange, I have no idea why, because the software works here just so well. So it turns out that you probably sometimes need to do some investigation of a production environment. The first question that you usually get, well, my software isn't responding, the web application doesn't seem to run, so the first question that you would normally ask an operating system, is my software even running? What you can do on a Linux box, and I focus on Linux boxes because it just so happens that in my past I didn't really work too much with Windows, and I'm happy this way, and I'm keeping it this way, so it's a choice. So the tools I'm going to show you do run on Windows, but I have no idea about the flags or the quirks or anything else. Because it's Java, they will be available. I'll base myself on Linux or around Linux. So you can do top, you can do htop, which means you'll get to see some of Java projects. And if you do PS and grep it for Java, you might see something like that. Which means, yes, there is Java somewhere there. The thing in the red frame, that's the Java command, and then you can see there is a lot of things happening later. Of course, we all know that what we get to see in here is the class path, which is just a feature. This is what it works like. There is a lot of flags, there is a lot of things happening in there, but at least we know that the process is running. What else can we tell from here? From just a PS, not much, unfortunately. And because of that, because Java ships with its own version of PS, well, we can try running JPS. So JPS is like PS for Java because, well, everything is slightly different when you want to do it in Java. So when you do run JPS, what you get by default is not really useful. You get the process numbers and you get the main class. And it's not even the fully qualified main class. So that's how useful is that? Not so much. What can you do? Well, you can add, of course, some flags, and you'll see that the set of flags that the tools under bin directory accept are not very consistent. So for JPS, it's an easy way to remember. You know that Java processes love memory, so the set of flags to treat JPS with is -LVM. What does it give us? Well, it gives us a bit more. So it gives us the PID, it gives us the fully qualified main class, it gives us the params, and it gives us the flags. So at least we know we have a starting point. We can see what parameters were put into the application. We can see what flags have been put into the application, which means, okay, this looks good, this looks totally wrong. Well, it's a start. And we know the PID, well, we can go somewhere, can at least start to go somewhere from there. And because, DevOps Borat once said that, something about probably about Java being verbose, if I read it correctly. So, let's look what's actually running. First, let's have a look inside the code. You know jar. Jar is a file format that we love because we get to live with that everywhere. And jar is also a binary that lives under the bin directory. So a useful thing for when you have a no class defined is to do jar -tf. Why? Because it will give you a list of what's actually in a jar file. If you have been running into class couldn't be found, or you're getting the wrong version of a class, the first thing to do is to identify, okay, which jar actually stores the class that you're looking for, which is very easy if you're using a tool which relies on a decent set of jar files, like, if you're using Maven or SBT, it might be easier. If you're using something that's shipped by a third-party provider that was so kind to take a couple of existing open source libraries and put their jars and their class files into their source tree, then it means that you might have a couple of copies of, I don't know, Apache Digester, because why not? Or maybe a couple of versions of JAXB. Yes, because why not? Because it leads to all kinds of fun. So sometimes you actually have to go through this investigation. Those moments are not nice, but knowing that you can do it from the command line helps. Because unfortunately, at least from my experience, the most of times when it actually happens is when it's in production and you can only, again, VPN over Citrix, over SSH, over something else, over a dozen of tunnels, which means you will not get X window in there. You'll not get a visual interface. You'll only get a command line. So with command line, you have to do. So we know which jar has the class file that we're looking for, and we know what javac does. Javac is the compiler. I was at first, well, purely relying on the compiler that has been, well, that the IDE invoked by itself. Then I learned that, well, javac is there. So with javac, well, it's just the compiler. There is almost no magic there, unless somebody is using Eclipse C to compile their software. Because, of course, you can. And some people do, and then it sometimes gets funny. How do I look into what javac produces? Well, there is a tool called JavaP. JavaP will, well, that's the source file. It's pretty, well, let's call it a piece of software that makes sense. It doesn't, because it's just something that spins and does nothing reasonable. It's just to occupy the, for me to have something to play with that. After we compile that, and after we run javap -v, well, we get to see some information about the class file. We get to see when the file was last modified. So if you've been frantically and repeatedly compiling a piece of source and you still get to see the old behavior, you might want to log into your application server and see if that class file actually made it all the way there, because it might be that you have a bug in your build system. It happens, unfortunately. It did in my time. You also get an MD5 checksum. Your intuition tells you right. The MD5 of what you compile locally should match the MD5 of what you see on the server or the machine you're investigating. If it doesn't, you have a funny problem somewhere in the way. You also get the information about the major-minor version, because sometimes somebody does something funny here. Also, if you've seen a major-minor version mismatch, it means that you're trying to run a class file with a Java that it's not designed for. That happens. You get to see the constant pool, and you probably have heard about the constant optimization that Java does during compilation, as in the constant value, instead of being referenced, it just gets put into the every place where it's referenced from. Which means if you have a string that's referenced from a file, and then you change that constant, but you don't recompile all the sources, it means you'll get the old version of the string everywhere else, which leads to funny problems, especially if that's a JDBC URL or some other configuration value, which happens so often because, yes, I know I should externalize all my configuration, I should put it all in property files or put it elsewhere, but the reality is sometimes there is this tiny little value that just sticks. And JavaP can actually tell you what the values of constants are, which for the crazy moments when you actually have to dig and it doesn't make any sense, it allows you to eliminate one constant after the other that it's not the culprit. Helpful very often, not really, but when it is, it might save you. So we know how to get into the class files. JavaP can also show you what the bytecode looks like, but we can actually we can give it a look. But I will not get into too much details. So let's find the class file. Let's look at what's possible. -vp doesn't work, so I want to do -v. And yes, we can look at the bytecode as well. We can see the modifiers. If you want to learn more about bytecode, that's beyond this talk. There is a lot of documentation online, but you can actually look into any class file that runs inside the JVM. If it comes from Scala, it will compile to that very same bytecode. That's what we love JVM for. If it runs on Groovy, the same. If it runs on, I don't know, Python, Gosu, pick your favorite language of choice that runs on the JVM, you will still go through bytecode, and then from bytecode you will go forward. So jinfo. I wanted to demo that, so do I have? Yeah, I do have a jinfo. Welcome to macOS. The numbers that you get to see in behind are from just something that executes in the background. What does jinfo do? It prints the first. You can see the. Let's do it this way, and we can. Now we have a victim or a suspect. Let's call it a suspect. I think it's a nicer word. So what we get to see here are all the flags. You can see the Java runtime version. You can see the boot library. You can see all the system properties that you get a JVM that's running with, and you can see the VM flags. Is that useful? Well, in most cases it won't. When is it? When you're trying to see all the flags because something doesn't really make sense. If the process you're running seems to have a very strange home directory, if it seems to have a very strange file separator, if it seems to have a very strange something, and the only source of that is system.get, this is how you can actually verify, okay, what is that process? What are the system properties that are running on that very JVM? It also gives you the VM flags. Why is that important? Because some of them can be changed, especially those. Yeah, Tomek. Tomek mentioned that if I have a manageable flag, how often can I actually change it? How often do I succeed? So I'll pause the answer to that question for a moment. First of all, you can see all the flags, and then some of them can be changed. And I'm saying some, and I'm not giving you a listing, which is an indication of something. The something I'm pointing at is the complete list of flags that can be changed changes from one JDK release to the other. So if you want to know what flags can be changed in your very specific build of the JDK, you have to check. You have to consult the release notes, the documentation, because Oracle are kind enough to expand the list of flags that can be changed during runtime, which is useful. Now coming back to Tomek's question, when do I succeed? How often does it work? The answer, of course, because we're all dealing with computers, is it depends. Is there a pattern? Well, some flags in certain circumstances will work, some will not. And again, it changes from JDK release to JDK release, because those flags are tied to how, let's say, the garbage collector is configured, to how other insides of the JDK are configured. So is there a golden rule? Yes, test. For more details, I will be very happy to have the conversation after the talk, because I have to be mindful of the time. But yeah, and one important thing is those flags that can be changed are called manageable flags. So if you want to look for it online, manageable flags it is. Now Java, because we're in the Java land, so instead of doing a pmap, we will be doing a JMap. That's a very simple script. What it does is, well, it launches some application called looper, which you have already seen, which loops and does nothing else. Then we get the process number, then we try to do JMap minus, as you can see in the last line, it's minus dump live format equals b file equals something, and then you give it the process number, which your intuition tells you correctly gives you a heap dump. So what do you do with such a heap dump? Why do you want to take a heap dump? Well, because imagine you have a memory leak, or you suspect a memory leak, or you have something strange happening in your process in production. Well, first of all, you're not going to connect with a debugger to a production instance of your application, because that's not really going to play that well, because it will kill your production environment. And I know of people who have tried to connect with a debugger to an Elasticsearch cluster, and it killed the cluster. Yes, because it means the node that you connect to is probably going to run so completely out of time and out of sync with the other nodes that it's not going to work. So what you want to do if you want to examine memory, you want to take this a snapshot of the memory, which is the heap dump, and take it, ship it to a separate machine and analyze it in peace when you don't really have to worry about anything. So assuming we have done a dump like this line mentions, we should now look at something called Jhat, because of course we need to open that with something. So I have a couple of heap dumps. This looks perfectly. I'm not choosing them by looking for anything in particular, because it's just some random heap dumps. And the important thing that you get from Jhat is started HTTP server on port 7000. Curious me will go to port 7000. What do I get to see in here? Well, I get to see an interface, and it's a very plain HTML, almost boring. Sorry, no Angular, no jQuery, nothing fancy. But that means, well, you can explore that with links, or your favorite terminal browser of choice, or you can even run curl against it, or run some scripts against an automatically taken heap dump, which also means that you can build in some scriptable automation, which your admins probably will love. What you can do, well, you can see all the classes in a platform. You can see all the members that. It's basically analyzing a heap dump. This is far beyond the length of this talk for me to teach you how to analyze heap dumps, and there are excellent articles available online. But what I want to show you is one particular thing. There is something that's called OQL, or Object Query Language, and your intuition tells you correctly. It's an SQL variant or an SQL-like language for analyzing heap dumps. So if you want to look for objects that, oh silly me, have, I don't know, let's take the first example, that let's see all the strings that have a length of longer than 100, and we can execute, and we get some items. And let's say, okay, maybe there is something longer than 200, and yes. And the good part, or the great part, is you can, because it's a heap dump, you can analyze all the fields of all your objects on your heap. So if you want to express a very particular map that has some keys and something at a very specific position, you can. If you want to look for strings that have something inside, you can. How does OQL work? Well, the reference is built into the tool, and it's a plain old HTML website, which means you don't really have to worry. If you want to find all objects that are reachable, that descend from properties or from a map, or from, I don't know, if you're investigating JDBC drivers, because maybe there is a MySQL hanging somewhere and that's interrupting your garbage collection, you can do it. You can analyze it from here. And how to do it well? Again, I will refer to the internet. Use Stack Overflow. Use articles available on Oracle. I'm not going to teach you that during the next, well, 20 minutes, unfortunately. The important thing is that OQL is also present in NetBeans. It's also present in JVisualVM. It's the very same runtime. So once you learn the tool, it will save your life. It might save your lives, and it can save your lives in a number of tools. Tomek, again. Tomek mentions that in JVisualVM I want to install OQL syntax support, and yes, that's a correct remark, but we'll get to JVisualVM towards the end. So one important thing that I should mention when we are observing and analyzing heap dumps: if your heap dump takes 32 gigabytes, it means that you should analyze it on a server that has at least that much of memory. Because if you're doing it on a notebook, you will start entering, you'll enter the swap lines, you will enter you'll start referencing memory that sits on your hard drive, which will get very, very, very slow. So if you want to analyze your production machine, you probably want to analyze that on something that's like your production machine, which is trivial if you are on Amazon, because spinning yet another instance just for a minute is easy, which is sometimes very, very hard if your hardware is, well, hard to get. But, well, to do it well, you have to have a machine that allows you to navigate the set of objects that it has that a different computer had in memory, because otherwise it will be very, very slow, and then it will make all of your investigation slow. And as you can see, well, you can see that you can go descend into the object graph as you would expect. Demo we've just seen, and stack traces. So now a question. Well, how do you get a stack trace of a process that's running on your Linux box? And you might have already seen the answer. So you do a kill -3. But there is a caveat, of course. If you do a kill -3 to a PID, where will the output go? Where will you see the stack trace? Yes, standard out. Unfortunately, I don't have any prizes to give out, but I would if I had, because that's the correct answer. This will go onto the standard out of the process that you are investigating. Which, if you're running Tomcat, if you're running, I don't know, WebLogic, if you're running something, and either capture all the logs from system out, then it means that there will be some lines somewhere in between everything else. Or in the worst case, well, if you're putting everything into dev now, you'll never get it. So what can you do? Well, luckily, somebody back in Sun was mindful of that situation, and there is a tool called JStuck. So let's run our friend Looper. Oops. Oh, that's... And what do we get in here? Well, we get to see all of the threads. So it works. So we get to see the compiler threads, we get to see the finalizer, we get to see the reference handler, we get to see the GC threads, which is pretty amazing. It also means that, well, what else you get in here? You get to see the thread ID, not that interesting, but you get to see the NID, which is the thread number. As you can see, it's in hexadecimal, so if you want to connect those threads with the threads that HTOP or PS will show you, you will have to convert decimal to binary, decimal to hex or vice versa. But it's possible. And I've learned about this because we've had this application in which one thread, when the application was doing nothing, was taking 100% of the CPU. The story was, it was one of the GC threads, which seems awkward, so we took a heap dump, and it didn't make any sense because there was almost nothing to collect. So then, long story short, it turned out that one of the VMs has just corrupted itself, so we had to, well, get rid of that and create a new one because some part of the standard library has been, well, completely trashed. But JStuck, one more thing, the stack trace, you would expect it to be like a snapshot through all your threads. Unfortunately, this is not the case. It's only at save points and one thread at a time. If you know what save points are, well, good. If not, those are, well, special places in which threads wait to see if they should wait or they should proceed because they have to enable garbage collection. I know this is not a perfect definition, but for the needs of this talk, it will have to do. To give you an illustration, it will be something like that. And of course, don't expect any sort of ordering in which all the threads will have their data collected from, because you don't have any control over that. What it means is if you have very short methods, you might not see anything. If you have, or you might see the same method being executed in a couple of different threads at the same time, or it seems like the same time because in reality it's not. What it also means is, well, you get to see the thread ID and a demo, but let's examine the output that we have in here. You can see the thread state. So we can see if the thread is waiting or if the thread is running, or if you can see, it will also show you if the thread is blocked. So if there is a deadlock, JStuck can show you that there is an obvious deadlock happening in your code. It will also, if there are threads waiting for a monitor, you can make JStuck show which thread owns the monitor, which means it makes the investigation a bit easier. And my favorite bit for those of you that have long-running transactions, and long-running transactions meaning a couple of seconds or more, you have a way of interacting from your software with the JStuck output. If you can actually set the thread names that you run in. So if you put your transaction name or transaction identifier into the current thread name every time you enter a new transaction, it means that later you can actually have a reference from, well, this transaction is taking this much time or is appearing this often in the stack trace. It makes no sense if your transactions are a couple seconds long or shorter, but for sending an email link well, sending a bunch of emails that takes, let's say, an hour, and you have a thread that governs that, it might be very helpful. It might, but you have to see for yourselves. A demo, yes, we've seen. And now JStat. JStat's syntax is like that. Who here knows VMstat, IOstat, or recalls such tools? Yeah, a couple of hands in the audience. JStat is exactly as you would expect. It's to give you statistics about a JVM. So let's have a demo, because that will be more useful. I think that always breaks. So what we get is some output. Let me decrease the font so the line doesn't break in such a way. We get some columns, we get timestamps, we get parameters about the JVM. The parameters I requested are, well, which ones did I request? That's governed by the GC flag. Where are all the flags listed? Well, they are in the documentation and they are also in the JDK sources. Is that useful? To a degree. The most useful thing is that you can actually, well, go to page. The internet work? Yes, it did. So all the options that you have available in your runtime are in the sources. So you can go and look what's there. All the formats that are available are defined here as well. What's cool about but it's not in the sources, is that you can define your custom formats, put that into your home directory, and then have something very customized, something tailored to your needs, and then that will keep informing you about, well, I don't know, your add-in sizes, your well, whatever you need, you can get from through JStat, which is pretty awesome. And well, some of the other flags, well, what's the delay between every single collection? How often should you print the header line? You could ask why, because, well, you can have a bunch of processes that log into the same log file, or somebody else also puts so much stuff into the same console that you want to have maybe your parsing job done in a more easy way. Up to you. You know where the documentation lies, so that's easy. JStudy is something that is theoretically supposed to expose that over the network. I don't find it very stable. I don't think it's supported. I don't think it's recommended to be used. So I'll just mention that it might work for you, but I don't use it too much. For me, from my personal experience, it's so much easier to have an SSH tunnel and then connect to a process running on a different server than using JStudy. I'll just mention that for completeness sake. JCMD is, well, we're finally getting to, well, Java 1.7 and to the current world. In the beginning, I asked who is before 1.7, because in 1.7, Oracle was kind enough to give us JCMD, and JCMD is supposed to be a tool that clears all the mess with all the tools that we've seen before, which means it can do what these tools can. Let's, well, clear that. Let's zoom in. Let's run JCMD. By default, JCMD runs, well, what JPS does. We already see that. So, nope. So, not like that. So we can do JCMD, well, help with a process. And the process is already gone. Maybe I should run that again. Yes, that is part of the problem. So I can ask JCMD about the options that are available for a given process. And you can see that the following options are available. And I'm showing it to you, and I mentioned different JDK versions, and I mentioned that this has been introduced in Java 1.7, which means, yes, as you expect, those things change. There is new options are being enabled or added, or new things are being, well, this is not a static list, this is not a complete list. You have to see for yourselves what's available, what's possible in the JDK release that you're using in your production. what can we see? Well, we can see, let's say, well, VM version. That's trivial. We can ask the GC to run. We can take a heap dump with JCMD, which we can also do with JMap. We can rotate GC logs. We can start and stop Java flight recorder. Basically, we can do everything that we could have done with the tools that you've seen before. Which one would I now recommend for you to use? If you're on 1.7 or newer, don't bother with the previous tools you've seen, because you have everything available to you in a single command. It's just easier to remember one thing for everything if you didn't know about everything else. I unfortunately or fortunately, well, have had a number of problems that I had to troubleshoot with before JCMD came into existence, so I wanted to show you something for the completeness sake. And now, a very last tool called Visual VM. Who here has used JVisual VM? Yay, so many people. So it's the first visual tool and the only one that we'll see here. What it can do, well, let's assume we will examine JVisual VM's process itself. You can see the JVM arguments as you could with the command line tools before. You can see the system properties, as I mentioned before and as I have shown you before. And now we can come back to Tomek's remark from earlier. Tomek mentioned that you can install OQL support. Well, JVisual VM has plugins. One thing that Tomek recommends is, well, OQL syntax. One thing that I usually like to recommend people install is Visual GC, because it means that anytime you want to have a conversation about how GC works on a process, you can have it visual. And I know a picture speaks 1,000 words, but a moving picture speaks even more. Well, installing a plugin is exactly as you would expect, so let's skip that part. And Visual GC will show you what's happening, how occupied are the spaces. Is that useful? If you're doing that, if you're examining it during, well, development or a production run, it might. It's still so much more useful if you have access to the process, so that you can have some visual information, because I am not that great at analyzing pure numbers in a console. Of course, if a console is all I have, then I can make inference information out of that, but this is just easier. And I wanted to show that to you. But to have Visual GC available to you, you need to have a plugin. What else can JVisual VM do? Well, you can ask it to perform a GC. You can make a heap dump, as you could with Jhat. Let's take one. You can see the classes, so a histogram, as we have seen before in a very, very crude way. You can see instances of specific classes if you define them, and you can see the OQL console. And that's the very same OQL that you have seen before available through a browser, but now in a desktop and visual tool. This is exactly the same that will be available to you in the NetBeans profiler. So if you are on NetBeans, you have access to that as well. I find OQL very, very useful. There are quirks or caveats which happen to you if you work with large heaps and you want to analyze large heaps, because sometimes it just takes a bit of time to analyze something. And we've seen this, we've seen that, and we have 5 more minutes. So if you have any questions, just start raising your hands. And before I say thank you, well, the organizers asked me to say that Northpoint will be sponsoring lunch, because it's still 5 minutes before they do. But, well, you're all invited for that, and now we have a couple of minutes for questions. Yeah?
You didn't mention JConsole. Why?
I didn't mention JConsole. Why? Yes, I didn't mention JConsole, because I was afraid I would run out of time. Frankly, there are more tools in there, but last time I did this talk, it took me an hour and a half, because I had no time restrictions. So I wanted to make sure that I will put the most important things in here. That's it. There is a question in the back. Yes, so there is a JVisual VM can connect to remote processes exposed via JStudy or let's say SSH tunnels. So yes, you can define hosts, remote hosts that would have. Well, let's actually not talk about it, but let's see what I can do here. I can define a host. Let's call it Alama Kota, which is a very old spell from an ancient country. Well, it's not a valid host name, unfortunately. So host name, I don't know. Something. Display name. JDays is awesome. Yay. We are so creative, and now we can add a JMX connection to something running on that host. We can, well, give it a display name, or we can add a JStudy connection. So you can connect to processes running on something remote. The problem is you'll get some network overhead. If it's running through some tunnels, through some places far away, it means you introduce latency over. Does it hurt you? Well, it depends on your user case, on how critical the application is, on what you want to do. The command line tools that you've seen before, or JCMD, all run on the command line, which means the amount of bandwidth that's needed is almost none. It's a very, well, it's a much bigger almost than none, but still it's so much easier to transfer some text over the wire than having a full-blown, well, X window. So, any more questions? Yeah. So the question is, if I'm running some piece of software with a very old version of the JVM and I have some problems, does it make sense for me to upgrade? Yes? So can I use the tools from a JDK 8 to examine an older version of the of a JVM? To some extent, I would be able. I would only be comfortable saying. I don't know exactly. Well, how far can it go? You can use JCMD from JDK 8 to examine a JVM that's running in 7. That's for sure. But you might end up in some compatibility quirks. If you, depending on very specific versions of the JVM that you're running, I would suggest trying out, because if you have that JVM, well, you can probably run a silly process that just spins a loop and sleeps all the time, and then see how much you can do. I can't give you a blank answer, and I don't think there is a web page even that describes it in all the possible details. So you have to test your own specific case. And I think that's it. Then thank you very much for your attention. Enjoy the lunch.